Okay, great. We're talking with Umesh Krishnaswamy, who's a principal dev lead in the Azure networking group at Microsoft. He's working on SDN WAN types of things, and we're going to talk today with Umesh about SDN WAN. So this is pretty cool. Thanks,
Hey
Umesh.
Nick, thank you. Hey, how are you?
Great. So yeah, let's talk a bit about SDN WAN. This is definitely something that has come up really in the past year. It's become a lot of things have started to happen just in the past year. I'm wondering sort of where this is all coming from all of a sudden. I mean, are there problems that people are facing in WAN settings that just current protocols are not well suited to solve that are forcing you and others to kind of look at SDN for better solutions?
So protocols is probably one dimension. I think the bigger one is in terms of if you look at today's wide area networks as used within cloud providers like Microsoft, they have you know they have there are high operational costs to such wide area networks. We have the historically it has been that you build these wide area networks using these extremely expensive devices that are with a huge amount of control planes intelligence in it, a lot of distributed and logic and so on and so forth, and that just adds to the operational costs. Now, and then afterwards, when it comes to maintaining them, troubleshooting incidents, they take time, and time results are what we call they cause these kinds of things that take a long time to fix. Actually adds to the cost of the whole thing. So, and as we are looking at our trajectory, traffic keeps on growing. These networks become they kind of we can do better with these networks, and that's probably the reason that what makes us look at different ways of building the WAN, and SDN is one is one way of tackling that WAN problem.
Yeah, you mentioned like troubleshooting, for example, and certainly BGP in particular has a lot of, I would say, known problems with convergence speed, stability, security. The list goes on and on. I mean, in your experience thus far with SDN in the WAN, have you faced do you face problems like this? I mean, you mentioned troubleshooting specifically, but other kinds of things where, I mean, do you think SDN will provide a solution to any of these things that people have been sort of complaining about with wide area network protocols for so long?
Yeah, I think in the case of we've had good experience with BGP. We use BGP extensively, and the thing is this that it's so yeah, BGP is actually fine, and you actually need something like BGP when you're there. You talk about this, you got to use something to be able to exchange routes, and BGP works out perfectly well for that. It's a matter of and there's a it's you can easily it's very well understood how to design networks using BGP. The problem comes around in the WAN, as I said, when people start doing traffic engineering using MPLS. When traffic engineering is done using MPLS, that's where it becomes the software becomes it's only provided by a very small number of providers. That's when the kind of the specialization really increases, and that's where when we do MPLS-based traffic engineering, you have things. The network works in ways that are hard for us to control, such as, for example, parts. You'll have traffic engineering being done with, say, local information, and we've shown in the Swan paper, that when you have global information, you can do better. There's lack of application information that comes into traffic engineering. All of those kinds of things. It's that piece of the problem on the WAN that SDN is good to solve. And the point is this, that you need, and I like BGP from the perspective that if you want to bring up a network with absolutely no controller, you need a distributed protocol, and you need a way for these things to come up, and a BGP is a perfectly fine thing to use.
Yeah, that's very interesting because I think I remember kind of like when SDN was sort of first catching on, or people first started talking about it in industry, and people were saying, like, I mean, at least some people I remember talking to were saying, like, MPLS auto bandwidth will basically, that's going to solve all your problems. I don't need OpenFlow or SDN, and it seems to me like that maybe I mean, auto bandwidth isn't necessarily quite as auto as one might hope. Is that kind of what you're saying?
Yeah, there are. That is, yeah, the way auto bandwidth is used. It has there are like there's I remember seeing a Nanog article on that one, and auto bandwidth. Yeah, it has its challenges and so on. So that is certainly one aspect of it. Yes. Of the problems that come about with MPLS-T. But it's possible probably to build these kinds of networks without it. Then afterwards you got to, without using auto bandwidth too. Then afterwards you got to have it tried auto bandwidth came along to simplify the configuration thing. Is that when nobody can say what exactly are the bandwidth demands, so nobody knows how to size these MPLS LSPs. So auto bandwidth is a nice thing that vendor providers say, hey, we will solve it for you because we know exactly what is the bandwidth coming in. We will use that in our traffic engineering database to figure out new paths and then afterwards signal them automatically and so on. What then causes this is that it's now every MPLS device is doing this on its own, and it kind of it doesn't take an application input is the second part of it. So the first part is doing it on its own, so there isn't any global coordination, and so auto bandwidth can sometimes create may not find paths, may not it will choose a path which is not quite right. Then after the fact, it doesn't take application input into account. So what happens then is that so you got auto bandwidth doing something, but then after the application characteristics of the bandwidth usage are slightly different, and that causes the two to kind of be totally mismatched, and that again causes problems. So those are the few things.
Interesting. Yeah. So I mean, I guess going back to what you were saying before about BGP working just fine. I mean, like, could you imagine a setting where like BGP is just like the dissemination protocol for routes, but then you have like more intelligent control systems, like actually, applying logic that affects forwarding.
Yes, that is right.
Okay.
Yeah.
Okay.
In fact, that's pretty much it. And if you were to crack open an MPLS device, what you see in it is a BGP component, which is exchanging IP forwarding and resolving routes over an IP over a forwarding next stop. And then afterwards, you got this MPLS piece, and that's where that is setting up these circuits or tunnels, and the two of them are unique. They're these two parts that kind of are brought together inside a vendor device. All I'm saying is this, that I think we are fine on the IP side of it with the BGP piece. It's this other stuff which is over there, which is the MPLS piece, that I think if you can think of it as take that off and basically have an SDN control plane that does the traffic engineering and tells the switches what should be the TE fib. That would be a way of simplifying, solving the traffic engineering problem, but still retaining the nice properties of a BGP-based network or just an IP network, which is what you need. Even anyways, if you want to bring up an SDN network, you need to boot it up. To boot it up, you need there won't be any controller or anything like that. How do you boot up an SDN network? You can use BGP to boot it up, and then afterwards have the TE rules come in, and then afterwards traffic follows those paths. Something catastrophic happens, and you don't have a controller and all of those things, and you need to do something. You can again go back to this one state. True, there will be congestion and all of those kinds of things, but that would there are, but that's okay. That's a nice. So those are nice problems.
State or something. Yeah.
Yeah, exactly.
Yeah. Yeah. So yeah, it's interesting. I mean, traffic engineering is something I actually worked on myself, like interdomain TE, in the context of BGP, quite a bit. And I think like we encountered a whole bunch of problems. I mean, like one was basically predictability, right? So like it's just sort of like you tweak a local preference, and you can't, you got to figure out like, well, that's going to affect a route over here, and that's going to affect these other routes, and then you run into like protocol simulation or at least emulation kind of issues. That's one thing, is predictability. Another thing is sort of like, the knobs that you have are sort of like prefix based, and you've sort of got to figure out like, well, if I want to move this chunk of traffic, like, I need to find the right group of prefixes to do it. There are other problems maybe with stability and so forth. The other one, it certainly comes up in the interdomain setting, is like I could do something that then affects what my neighbor's choices are, and then that could affect my traffic matrix. So there are those kind of issues as well. I mean, I'm wondering, like, kind of in your experience, like, where do you think? I mean, do you see similar kinds of pain points, and where do you see with SDN, like which of these problems do you think it's like most well suited to solve? Like for example, could it be the case that it just makes things more predictable, or is it going to be that like the granularity that you can operate on is better, or it's easier to troubleshoot, or what do you think it is?
Yeah, no, there is when it comes to inter-domain, yeah, that's a whole different level of a problem. Um, I don't think SDN is mature enough to tackle like inter-domain, and we are. So, for example, if you were to look at when you got MPLS initially, and then after there was a single domain where people would do traffic engineering, and then afterwards you got inter-domain or inter-AS like based MPLS, and then problem kind of becomes harder. And you're absolutely right that all of those different knobs that are there to which are used today when it is when you do internet-facing route selection and route all of those kinds of things, they are yeah, you have to really make do with a lot of it tends to be a bit involved. One of the things is this is that it is if one simplifies the set of knobs one plays with, I think one models for BGP and we say, okay, these are the kinds of things that we're going to do, and you can model the network, and then afterwards restrict yourself to a few set of knobs that you play around with. You can kind of make the network easier to manage and maintain. And so that is a different aspect of SDN. Then that aspect of SDN is kind of more like, you can think of it as more like configuration and policy and those kinds of things. But I don't think it should be called SDN, because that stuff is already there, in the sense that what we do is that any large provider thinks of the network and models it in some fashion. And then afterwards, and that's where they get into all kinds of details of how they model the network, and then afterwards they spit out various kinds of configurations. Then afterwards they get pushed onto these devices, and you can call that as also SDN, but that's really doing network management part of it. Now, with that, what you can do is that you can really code all of your route maps or your route policy and all of those things in this model and then afterwards emit out configuration, which then gets pushed on devices. And when you can think in terms of the model, you can do simulations with the model. Probably you can do prefix compaction. Anything that you want to try, you can do it with that. Then you can kind of restrict yourself to a small subset of the BGP features and kind of get a bit more method into this whole thing. When somebody just directly goes and touches devices, directly goes and does things, they're in for some trouble. And I don't believe people do that even before there was this word called SDN. They were already doing this well. So now saying SDN is meant for configuration, I think it's a bit overloading of SDN. One could say that's network management, and with that one can get a bit more order when dealing with BGP within the domain or across domains.
How do you sort of separate the notion of this sort of configuration or management, as you're calling it, from these questions of like traffic engineering and control? I mean, it seems like on one hand you say SDN is quite useful for TE, and on the other hand, like, okay, well, we already kind of knew how to do certain kinds of network management tasks. So how do you kind of like partition or separate those two? How do we think about that?
We think of them as a federation of controllers. You can think of a federation of entities that are doing various global activities. And now the kind of global activities which is involved in configuration generation or network management, so to say, is one kind of a controller or a set of controller services. And they tend to operate at a slower scale, in the sense that you need to do them only when you're bringing in new devices into the network. You're going to make a major change to the configuration and all of those things. You exercise that suite of controller capabilities. Now, there's a different controller which would do, say, monitoring of a whole network, and that handles all kinds of network analytics, network data collection, analytics, and all of those kinds of things. Then after, there's a third class of a controller which is doing traffic engineering, and that really is taking various kinds of inputs about the network, doing an optimization of the how traffic should be placed on the network, and then afterwards programming of the TE fib onto the network. It is, what happens outside. I think there's this whole thing about trying to think of a God controller, like one controller that does everything. That's mistaken. Doesn't exist. It's not needed because naturally, if you were to see it too, these are all like They are different. There are different classes of problems, and it's better to build a what is called a controller. That framework is completely different for each one of these class of problems, and best to take it separately. And so that's how we have it too. We have a federation of controllers.
Do you think that there are maybe, I mean, one of the things that that researchers have looked at certainly is how to like compose control programs. That's something also that students are looking at as well.
Yeah.
And do you think when you have a federation like that, that you have to think about, well, this controller is doing TE, but this one's doing, other kinds of management tasks, security or access control. Like, do we need to think about how those two things compose or interact? Like, if you have these different controllers talking to the same set of switches, like, do you face, potential conflicts or other things, or how does that play out?
Yeah, that does. That can happen in the sense that you'd have, you know, you, and so there's this work that we've been doing in this thing called Statesman, where you talk about this thing, or you got like state that you want to put onto the network devices, and you have think of it as what is the current observed state on the network. And then afterwards, you were to say, if people were to say, okay, this is a change that we would like to do, and this is a proposed state. And then afterwards, they can have these things that will check that, yes, this is something that's valid, and then afterwards, take it from the proposed to what is the target state. So you can do these kinds of, you can, so you can kind of bring it down to where there's going to be conflict in the things that are going to be done on the network. You kind of use a layer like Statesman, which is nothing but a state database, and that has got state, which is what's on the observed on the network, what we want to take it to, and how do we get there, and build that. So it's possible to build it like that. We have slowly started to use this kind of thing for within our data center actually, and we are starting to explore it for the wide area network too.
That's interesting. So in other words, you sort of like look at the state that's in the network. You try to basically detect things that are inconsistent or otherwise undesirable, and then you kind of go back and correct them after the fact. Is that?
Yeah, that's right. Now, one thing is that when it comes to to traffic engineering, which is the one where I've been spending more of the time, they only the kind of state interactions with regards to, hey, is a switch up or down, and all of those kinds of things, or the switch going through some kind of configuration, there are very few kind of interactions. The amount of stuff that, say, a traffic engineering controller pushes is really a fib, and that is the order of operation. Should a switch be in the process of being reprogrammed, or like something else, it will just show up as a topology change to the traffic engineering controller, and the traffic engineering controller will just address that. So sometimes I think the TE piece controller tends to work at a level of a fib, and these other kinds of events that are like, which are like a switch level event or a maintenance event, they all get modeled as, oh, here's a link that I should not use when I'm trying to I should not put traffic on it. So the interactions between the kind of like the network management controller and the traffic engineering controller, they really come down to basically topology events that are there. It's like, hey, here's a topology event because somebody is going and bringing down an interface to do maintenance on that interface, or somebody is going to take the switch down because they want to replace that switch with something else. That just shows up as a topology change, and then the traffic engineering then afterwards goes and bypasses that. So,
yeah, I mean, you talked a lot about traffic engineering. It seems, another thing I guess I've thought about in that area, worked on a little bit, is sort of trying to automate certain parts of this process, right? Sort of, and I think, certainly not new to that problem. That's sort of like a 20 or 30-year-old problem. This sort of load-aware traffic load balance or traffic engineering. This has been, like, I guess for a long time thought to be unsolvable, right? I mean, like the ARPANET had sort of load-aware traffic engineering or link tuning, you might say. People try to solve this in various settings. It's I think there's been some work that's it's done this with tunnels like TechCP, but by and large, like there have been like lots of stability questions. Do you think that I mean, how serious are these stability questions in practice, and how, like, do you see SDN playing a role in solving these problems? If they're even, I mean, if these are things to worry about, like, do you think that SDN can provide some help?
Yeah, they are. So yeah, it's a case that the traffic engineering solver. That's the sophistication that needs to go into a traffic engineering solver to be aware of say the of various kinds of parameters, be it the load that is like, and I look at load aware as basically knowing certain characteristics about the application demands and being able to influence that. Now, there is a now certainly with SDN, you have the ability to take all of these inputs and do put more compute cycles into it and do more sophisticated computation of what the TE schedule should be. That is there, but I think then afterwards there is a how to make these guys work at scale, and those are probably, I think they're still open problems. We have, as you know, if you look at SDN for the WAN, we've kind of taken on simpler networks to do SDN for the WAN. Simpler networks, by that I mean like inter-data center wide area network. That's a simpler network. Using it towards
Simpler in the sense that like the traffic loads are more predictable, or the topology is more regular, or all the above.
Both, all of the above. You got traffic is not unruly. You got like, it's not like the wild internet, and you got the scale in terms of the number of prefixes you're dealing with, the scale in terms of the number of tunnels you're dealing with, and yeah, you have, as one of the things is we've talked about in the Swan paper is this, that a lot of traffic engineering is how you can get great benefits of traffic engineering is twofold. One is global knowledge, and the second one is being able to influence the applications putting traffic on it in some way by bandwidth control so that they don't stomp on each other. And that has also shown us to be able to run the network hotter and basically get higher utilization. So in an inter-data center network, those are things that are easier to, they are like, you're able to be, we know how to control those kinds of things. When it comes to a network which is going towards more on the peering side, you've got the scale completely goes up. You've got, and that's where I think there are. So that's why I call it a more complex network. And SDN for that, and I think of. And that's where I think one should try and solve that problem too, and that's SDN for the internet-facing WAN or the peering side, peering role, as opposed to an inter-data center role. It's
It seems like there are a bunch of challenges and opportunities there. I mean, like you mentioned a couple, like scale being one of them. I guess the unruliness of traffic being another. Do you think there are other challenges on as we were to move, if we were to move SDN towards the interdomain or peering kind of settings? Like, what other challenges come up there?
The other one is bandwidth control. How do you how do you recognize what are the different applications and what are their bandwidth needs, and then afterwards, if they're is it possible to not just like and being able to kind of control their bandwidths in some fashion? And I think one has to take it on a more application by application basis. And that you can't do that when it is on the peering side. You're not looking at applications. So the bandwidth control probably becomes is another problem beyond the 2 points, which are the scale and so on. And now I think one of the things you got to think of is that when we try and build these kinds of devices, when the switches that we're trying to, there are like, there's also the kind of the capabilities of those switches at the data plane level to scale to what is needed on the internet-facing role. Then after you got the other part, is it again becomes how do you get software that is going to scale to internet-facing side, and that's the other part. So they've got a control plane software. You've got the data plane itself needs to be able to do it, and then after we just restrict ourselves to traffic engineering, it is these aspects of the bandwidth control.
Yeah. Yeah, absolutely. And I guess like I mean the challenges are certainly significant, but what about opportunities? I mean, you mentioned a little bit like, I mean, we talked about peering and things like that, but what do you think are like the biggest opportunities as you move like SDN to an interdomain or peering type of setting? I mean, do you see potential for new business relationships? I mean, there could be peering of certain kinds. There could be more, more dynamic things, more direct. There could even be remote control types of things. I mean, what do you see as like the, if there is a driving application or a driving factor in an SDN in an interdomain setting, what do you think it would be?
It would be. I think it could be. It could be. The opportunities are also in this. It would kind of line up with these three challenges which I mentioned, and I think it would be. And what could be take it as the opportunities on the TE side is how to build a very scalable TE solver when it is dealing with really large networks. And the second one would be around the bandwidth control. How do you do? And like how do you rather when I say bandwidth control, I mean like how do you deal with the application to network interplay that is you kind of taken as something that given in an inter data center WAN, but that's not a given in this one. So knowing about being able to, so that goes to a bit about like how one can, opportunities are in the area of how one can take various, like IP fix and NetFlow and SFlow and all of those kinds of ways of getting information about the flows, and then afterwards extrapolating that to say, okay, this is what it was meant by applications, and then afterwards being able to do something in terms of relaying some information back to the other domain about, hey, this is what, can you hold back on this? Establishing of contracts between application contracts between the network provider and the application user for bandwidth could be an opportunity, so that that can, you got to kind of simplify the problem a bit. You can't like say, hey, I'm going to be exactly how I was before and still expect XDN to do magic. It won't be the case. One has to kind of create some kind of these bandwidth contracts maybe, and do that. Then afterwards, if somebody is more like a hardware person, then really thinking about switches which can do can scale. I would say, let's just say, Whitebox switches, which can really scale to internet kind of loads. That would be a good one. It's really around like table sizes and supporting the standard encapsulations that we need for the WAN. The control plane probably is there, or probably not. I'm not sure, but it's really around. That's probably an engineering exercise.
That's very interesting. I mean, supposing we had this, I mean, it's really interesting what you had to say about the sort of application interplay and contracts with the network. Supposing we had that, like, what do you think would be possible? I mean, are we moving towards in-serve kind of stuff, end-to-end QoS for certain kinds of applications? Do you think there are other kinds of things that may become possible?
I think what will happen is that one will be able to, beyond the applications are going to be the way they are going to be. It's just that one is able to build the infrastructure with lesser, is able to run the infrastructure more efficiently. And it's, you could probably do a few of these kinds of interesting applications more on the back end side of, probably, for example, if you had no, so one is just a decreasing of the cost and the applications you take over. If it were to be like new applications, I'm not too sure what are the applications one could think of, but I would let the application guys do. Probably they could just be able to do a few things. Right now, applications are written with just purely running in a single region, right? If you had kind of contracts and you could kind of do various, you could probably run inter-region applications more easily. You could think of it as, say, I've got a private, I want to build a hybrid cloud, and I want to have some stuff running in an enterprise data center, some stuff in the cloud data center, and then afterwards, if there was some kind of contracts on that whole thing, then it may be possible for these applications to most seamlessly extend into the cloud and then afterwards be served from either place, because there are some kind of guarantees that you're able to get from the network, and so on. So this is where it really depends on the class of application, because you can't do that with interactive, but you could do that with like the other kinds of applications. So it goes on like that.
That seems very interesting. I mean, the sort of coupling of private cloud with public cloud settings also seems to bring up not only performance questions, but also security questions. Like, how do I make sure the data that is on my private cloud that shouldn't ever go to the public cloud, not go there? I mean, do you think that there are, security questions like that with the WAN in general? And what do you think are the big security questions? And do you think SDN has anything to say about security in the WAN?
The security applies even before there was this one, and I'm not a security expert, but I would say that I think, this is where we can have, but security is a problem that needs to be solved either way, whether it's a WAN that is based on SDN or a WAN that's not based on SDN. And you do have these security questions that do show up when when somebody's using the cloud versus the internal stuff. But I would say, I think when you break it down, you have these problems stay the same. They were already there, and probably, and I'm not sure how SDN would help and how it should do, because I've not spent much time thinking about it.
You have certainly, I mean, I guess other things you've thought about though, like, not more specifically to security, but I guess you've had other experiences even before you came to Microsoft with SDN and IP, and I'm wondering if you're, I'm just wondering how some of that work that you did in the past, like at ON Lab, for example, on SDN IP, how that kind of shaped your thinking about just SDN and the WAN. I don't know if that work is still going on, but certainly there are other people trying to basically, ourselves included, trying to couple, IP routers with SDN controllers. I'm curious, like, how that shaped your thinking.
Yeah, it was. Yeah, I think OpenLab is doing some really great work. In fact, they've since I was there working on a couple of projects. One was the one that you mentioned, is basically have an SDN a software-defined network interconnect. Basically, you can have SDN islands talk over an IP network, and so basically use BGP as the protocol that an SDN, a software-defined network, talks to an IP network, and that really makes a kind of because previously it was not there. Like, we'd have these SDN islands on all these different campuses, and they could not, they kind of did not talk to each other. There's probably an L2 circuit, and that's about it. But now with this, you can kind of have it, you can peer at L3. I believe now that is being folded in as an application on top of this other one, which is a controller work which I did, and that's really being it's still on. It's ongoing work at ON Labs, just ONOS, or Open Network Operating System, and that's really meant to be a distributed controller as opposed to a controller that runs on a single server. But it's meant to be a distributed controller that can actually be either geographically distributed, either distributed within a data center or distributed across data centers. And so we were really building distributed frameworks for that. And we had an SDN IP app as an application that would run on top of that. So both those are pieces that I think how they influenced is, I think, in terms of got to really step back from because I came from Juniper, so I was like a step away from like doing things on a device to doing things externally, and to start playing with these things. A few things that shaped my thinking were really around what were the capabilities of OpenFlow, what were the limitations of OpenFlow, what would be the way, when we try and build a controller, I think we would, do you build a controller that can do any application or make it more targeted to an application? And as you can see, what I've been telling you, if you heard what I said earlier, I've been kind of, I got to play around with these things, and they influenced what we're doing now. I think at Microsoft, the point is, has been eye-opening in the sense that we're operating at a scale which is tremendous. This is actually like, when you're in, I think when you're in a place like this, you kind of see we are actually a DevOps organization, so we do development and we do operations, and we are combined teams that do this. So a lot of understanding of what works, what doesn't work, what is important, what is not, all of those things kind of shape the thinking, and so it's still an evolution. It's still a learning process.
That's very interesting. Actually, you touched on one thing that shaped your thinking, which was sort of the importance of IP or layer 3 peering between these SDN islands as opposed to just sort of L2 circuits. I'm curious what your thoughts are on that, just because that seems to be a very hot topic of debate, at least in the academic and research communities right now, is like, how do we peer these SDN islands? And L2, L3 discussions are sort of right at the forefront. So what's your thought? I mean, like, when you were doing these L3 peerings, like, what kind of value did that bring to the table?
Actually, I'm surprised that that kind of discussion is going on in the academic world, because I think we've decided a long time ago that layer 2 just doesn't scale. You got, for example, within our data center, we don't we limit our use of L2 because you got like spanning tree protocol issues, spanning tree storms that can all happen. So that's but the thing is this: it's really easy to bring up an L2 network. You don't have to do a whole lot, and you can bring a network up. When you
Yep.
have to bring up an L3 network, it is hard. Like you got to have the software that will do it. You got to have the other things that will. You got to be able to. You need some protocol support. That is why the very first your sample program somebody writes on a controller is an L2 switch. But I think if but we are past those times when they are for like when you try to build like large networks, one has to be having a basic set of L3 capabilities. So this thing about and it is possible to build that on top of the protocol suite where we have, and you can use there are open source work like Quagga and all of those things that have got like they have been rejuvenated with more interest and more development as things that can run on top of an SDN control plane. And the SDN IP work that I talked about earlier really was using a version of Quagga, not because we are partnering with with the same folks who are with a different company who gave us that routing piece, but it was so having all of those things come on top of an SDN control plane, it kind of makes lets us create L3 networks that are under SDN control talking to other L3 networks, which is how the internet works.
Absolutely. So, I mean, why not, basically, right? I mean, if you have the ability to do the IP,
Exactly.
the IP peering with an SDN controller as you do now, it only helps you, right?
Exactly.
Yeah. One other thing I wanted to touch on that you talked about was like you talked about sort of the challenges of possibly scaling a white box switch, and that's something that certainly is coming like like getting a lot more attention in the past year or so as well. And what do you see as what do you see as the opportunities there? Because I mean, certainly I think some of the things we're looking at as we sort of like put switches into exchange points, so we're starting with like OpenFlow style firmware, but it sounds to me like you think maybe that's not what we should be doing. Maybe we should take a white box switch and put it there. But what's your opinion on that? I mean, what's the right way to go?
So here's the thing. What's happened with the original OpenFlow switches were built using Broadcom chips where or like any one of these kinds of chipsets, Broadcom, Intel, all of them and you have because OpenFlow was such a flexible such a flexible flow specification, the only way it was could be mapped onto the chipset was to use the resources in the chipset that do ACLs or access control lists. That is a very powerful engine in a chip, but that has got very limited amount of space. Most of the chip is devoted to doing L2. These are chips they tend to be used in the data center, so they got like exact match tables. They also have longest prefix match tables. Those are much larger, but OpenFlow would not be using them because OpenFlow rules were supposed to be so flexible. So I think the thing is so when we try and use these, so you try and use these devices. So that is one aspect of it. Trying to use it in the WAN. Direct using of just OpenFlow will not quite cut it because you've got to be able to kind of restrict what it is and then afterwards implement the agent on the switch that really implements what is called like that will program those resources. So one of the things that we've done is this thing called define a switch API that is most suited for programming fibs that are that have the WAN kind of scale and they map directly to the LPM and exact tables and exact match tables. Now, a white box switch can do this. The thing is that the agent that needs to implement now needs to take a switch API that I just talked about and compile it into those kinds of things. The other aspect of it is delay bandwidth buffers. These chips have got packet buffers that are inside the chip. So when they're inside the chip, they are much smaller. And when you're trying to be used, which is perfectly fine for an in-data center application. When one goes to a wide area network application, the delays are much larger, right? They're of the order of, let's say 50 milliseconds across the country. you got to have, and you want to be able to support a certain amount of bandwidth, you need to have larger delay bandwidth buffers. That means that one tries to build a white box switch, one has to have a chip that has got larger delay bandwidth buffers. Either that, or one must be focused on applications where there's been all of the Appenzeller work that was done about how you do TCP bandwidth study is scaling. That one could make, if one could kind of make use of the application and the kind of the number of TCP connections and all of those things, and try and make do with smaller delay bandwidth buffers. So when it comes to using a white box switch, one aspect of it is the agent work that needs to change a bit so that one uses the chip more efficiently, and the other one would be in figuring out for a wide area network the right kind of switching chip would be another area of investigation and opportunity.
Very, very interesting. I guess along these lines too, like have you taken much interest or paid much attention to the sort of custom chipsets that are OpenFlow specific or SDN specific chipsets that are being sort of tossed about, like the RMT stuff or protocol oblivious forwarding? These are some things that the students are looking at as well. But certainly, it seems like that gives you a place to start. I don't know. What's your opinion on that versus sort of like a white box switch kind of model?
Yeah, those look interesting, and certainly worth looking at. Given that for the time, and I know there are also like startups that are building new switches, chipsets that are more tuned for the OpenFlow and so on. I think it is so those do look very interesting. We sometimes have to think about you start with a chip, then afterwards you put it in a system, and then afterwards you have the software on the system that needs to be of some stability for us to be able to then afterwards use it in our network. So given that, I certainly believe we may be right now looking at certain kinds of things that are out there today, but it is certainly I would love to look further into the things that you mentioned.
Very cool. I guess just one final question. I mean, kind of going back to the WAN stuff, right? I guess some of the things we've encountered in some of our SDN exchange work, we'll say, hey, you can do this. You can do application-specific peering, or you could do time-of-day peering, or you could do inbound TE based on flow space, and sometimes we get these retorts like, oh yeah, but you can do that with BGP. You can use communities, or you can use BGP flow spec, or pick your protocol tweak of the day. Do you face that kind of tension? I mean, do you see there are things where it's like, well, actually we could just do this with BGP, or are there things that actually no, you can't do with BGP, or they're so hard to do with BGP that you do need some kind of the flexibility the SDN gives you, or is it the case that everything's pretty fine?
No, it's always there that there'll be things that can be done with BGP, and yeah, BGP has got a really rich set of capabilities, and the things that you mentioned, absolutely, I've gone through those. I've heard similar conversations. But yes, it can be done with this, but I believe when it comes to it is not that it cannot be done with BGP. It really comes down to which one is easier to build on. It's easier to build a service that is easy to operate, easy to configure, easy to troubleshoot, easy to monitor, and has got and suppose the next set of capabilities that need to be added, how easy is it to add them on to a implementation that uses BGP alone, or an implementation that is done differently, say using SDN with some other kinds of things. You will find that when one looks at it that way, internally at least, we are able to rationalize, yes, we would use, let's do this with BGP, or let's do that with something else. Within in Microsoft, we're really about trying to be able to build a service that is that has got a certain level of SLA, that has got a certain, we're able to scale it up with a small number of people, and when you have a service mindset, what happens then is the person who is developing the service is also the person who's offering the service. So then they are not like, it's not like a group which is developing software that is giving it up to somebody else who is supposed to operate it. It is one and the same group. So it gives freedom to the person who is offering the service to implement it the way they think it's right. Because at the end of it, they are the ones who are going to be handling the customer calls. So if that person were to say, hey, you know what, I can do it with BGP, well, go ahead. If they say, hey, I'm going to do this with this kind of a new software that I would like to write, they're free to do that. So
Yeah, no,
it's yeah.
that's a good
So that's how it
situation to
works
be in.
internally. Yes,
Yeah,
that is
no,
true.
that's a very good situation to be in. Cool. This was very enlightening. Thanks for your time, and I'm sure we'll have lots more to talk about with SDN and the WAN in the future as well. It's very exciting.
Absolutely. Likewise. Glad to help.
Thanks.